The night sky stretched out like a vast, dark canvas, silent and endless. Then, without warning, a streak of light cut through the blackness. Comet R2 Swan, blazing brighter than anyone had ever seen. It wasn't just a flicker or a faint glow. This was a sudden, dazzling surge, as if the heavens themselves had flipped a switch.
From the Naval Research Lab. Everything that you're seeing in this movie is based on actual data. So actually, every single dot that you see in this movie is a real comet that has been discovered or observed by SOHO.
Of the last century, a comet captured into orbit around a planet traveled too close and was shredded by its gravity into multiple pieces, some as large as half a mile or 1 kilometer long. Those fragments would plunge into the planet's atmosphere in a series of impacts. Would the impacts be spectacular, or would the comet fragments disappear without a trace? In July 1994, astronomers around the world watched with bated breath as the fragments of comet Shoemaker-Levy 9 slammed into the planet Jupiter.
Degrees of the Earth's orbital plane, the so-called ecliptic. So when we observe the sun with a coronagraph that blocks the much brighter light from the sun itself so we can see the faint corona, the sun's hot outermost atmosphere, we get occasional glimpses of planets.
This isn't just a comet, it's a celestial masterpiece, a fleeting moment of brilliance that reminds us how small we are in the grand design.
147 miles of the comet, taking the most detailed pictures ever captured. The pictures revealed a rugged surface of canyons hundreds of feet deep, towering pinnacles over 300 feet high, and violent spewing jets. During its closest flyby, Stardust was bombarded by millions of space particles from the jets.
That might not sound like much, but in the world of astronomy, it's a dramatic shift. Stars and comets don't usually pull tricks like this. It was a rare event, one that had scientists scrambling to understand what was happening. The comet wasn't just getting brighter, it was putting on a show, and everyone wanted to know why. The map unfurled across the screen, dotted with glowing markers from Tokyo to Buenos Aires, London to Sydney. Each point pulsed like a heartbeat, a silent testament to the night the sky lit up. It wasn't just one place, it was everywhere. Reports flooded in from backyard telescopes and high-tech observatories alike, all telling the same story. A burst of light, sudden and bright, seen by countless eyes across the globe. This wasn't some local flare or trick of the atmosphere. No, this was something bigger. A moment when the whole world looked up and saw the same thing at the same time. Amateurs with their modest setups and seasoned professionals with their precision instruments, all of them together confirming what had happened. It wasn't just an event.
On April 29th, a mile-long asteroid will make a close approach to Earth as it passes safely by. There's no need to worry, this asteroid will not even come close to hitting Earth. Our solar system is actually littered with asteroids and comets, and sometimes they do come very close to Earth. When an asteroid or comet could one day come close to our planet, it's known as a near-Earth object. But how close is close? A near-Earth object is defined as an object that could pass by our planet within 30 million miles. NASA begins to keep close watch on objects that could pass within 5 million miles of Earth.
It's like a pressure cooker with no lid. And when that gas finds a way out, it doesn't just seep, it erupts, sending dust and debris flying into the void. This isn't some quiet, dormant chunk of ice. It's a dynamic, unpredictable force. And those thermal models are our best clue to understanding what's really going on under the surface. The comet's not just sitting there, it's alive in a way. Deep inside, pressure's been building, trapped for who knows how long, and now it's found a way out. A weak spot in the surface gives way, and suddenly there's no holding back. Gas and dust explode outward, a violent burst of energy that's been waiting for this exact moment. It's not random, though. Scientists saw this coming, crunched the numbers, and here it is, right on schedule.
Far beyond
The comet's outburst matches predictions of a pressurized pocket venting, blasting gas and dust through new surface vents. Nature's got its own rhythm, and this is just part of the dance. The data came in crisp and clear, the spectroscopy readings painting a picture of what lay beneath the surface. The numbers told a story. Carbon dioxide and water locked together in a delicate balance. But this wasn't just any balance. The ratio was striking, 7.6 parts carbon dioxide to just 1 part water. That kind of concentration doesn't happen by accident. It's the kind of thing you see when something's been sealed away, untouched, for thousands of years. A reservoir, hidden and forgotten, holding its secrets tight. The science doesn't lie. This place had been closed off from the world for millennia, waiting for someone to finally take notice. On September 28th, the Sun released an M6.4 class flare, leading to a coronal mass ejection heading towards R2 Swan. The burst of energy rippled through space, a wave of charged particles surging outward with relentless force. It wasn't the largest flare ever recorded, but it was powerful enough to send a shockwave hurtling toward the distant station. R2 Swan, a quiet outpost on the edge of the solar system, had no way of knowing what was coming. The flare had already done its damage, and now the ejection was on its way, a silent storm, racing through the void. There was no sound, no warning, just the inevitable march of physics playing out across the cosmos. And somewhere in the darkness, R2 Swan waited, unaware of the energy headed straight for it. Hey there, early risers. If you've got a pair of binoculars lying around, now's the perfect time to put them to use. Before the sun even thinks about peeking over the horizon, grab a cozy spot and point those lenses toward R2 Swan. Trust me, it's worth setting that alarm a little earlier. There's something magical about that quiet, still moment just before dawn. The sky's got this deep, rich color, and if you're lucky, you might catch a glimpse of something truly special. R2 Swan is waiting, and with a little patience, you'll see why so many folks make this a morning ritual. Don't worry if you're not an expert. Just take your time, let your eyes adjust, and enjoy the show. Who knows what you'll spot? The key is to be there, ready and watching. So go on, give it a try. You won't regret it.